dear student, myself Amartip Jadhav, Assistant Professor in Chemistry, working in Pushpa Department, Arts and Science College Resort. Now today's topic of our discussion is BSc first year in Unit 4 Aromatic Hydrocarbons, and this is the fourth lecture of the aromatic hydrocarbons. In previous lecture, we have seen the synthesis of or the nitrogenation of benzene, its mechanism, and now in this lecture we are going to see the alkylation and halogenation reactions along with their mechanisms. Let's begin with the halogenation. Halogenation means what? Replacement of one of the hydrogen from the benzene by halogen is called halogenation of benzene. Halogen involves chlorine, bromine, fluorine and iodine. Okay, these four compounds or atoms are said to be halogens. Now, the example of halogenation of benzene is benzene on reaction with chlorine in presence of anhydrous AlCl3. Anhydrous means what? Anhydrous means what? A compound without any water molecule in it. Okay, anhydrous means without water. This AlCl3 acts as catalyst in this reaction and it gives chlorobenzene. The reaction is given as this is the benzene. This hydrogen is replaced by one of the chlorine from the chlorine gas in presence of the anhydrous AlCl3 catalyst to give us the chlorobenzene along with the evolution of the hydrochloric acid as a byproduct. Now, what is the mechanism of this reaction? This halogenation reaction of benzene involves three steps. Step 1 is the formation of electrophile. Okay, as in the nitration reaction also we have seen the first step involved in mechanism of nitration of benzene is the formation of the electrophile. The nitronium ion is going to get formed. Here the chloronium ion is going to get formed. Okay, what happens over here? Chlorine reacts with catalyst, and what is the catalyst here? That is the anhydrous AlCl3. Okay, this anhydrous AlCl3 to give a chloronium ion. This IUM in the end of the word suggests that it is a positively charged species. Okay, IUM. Okay, IUM suggests that this species is positively charged. Okay, as an electrophile. When this chlorine reacts with the AlCl3 to give Cl plus, that is chloronium ion, plus AlCl4 minus, and this is act as a base. What it act as? It is acting as a base in the coming reaction. Okay, this is going to get used as a base in the coming mechanism steps. Okay, so just keep in mind here chloronium ion is generated and AlCl4 base is also generated in the first step, that is the formation of the electrophile. Then mechanism involves the second step, that is the next step is formation of the sigma complex. What happens over here? This formed chloronium ion attacks on the benzene ring to give the carbonium ion intermediate, and that intermediate is known as sigma complex. As we have seen in the previous reaction of nitration of benzene also, second step is the formation of the sigma complex, and this is the resonance stabilized sigma complex is formed in this reaction, and this step second of this mechanism is very slow, and hence it is a rate determining step, or the RDS. Okay, RDS stands for rate determining steps. So what happened over here? This is the nucleophilic species, and this electrophile is going to get attacked onto the benzene ring this way. Okay, and what happens? This is going to get over here, and positive charge is generated on this carbon like this. Okay, this is the structure number first. But what happens over here? This bond shifts in between these two carbons like this to give us double bond over here, and this positive charge gets shifts onto this carbon. Okay, and this is the resonating structure 2. Now what happens over here? This double bond again gets moved in between these two carbons, and this positive charge will shift on this carbon like this. Okay, this type of the 3 resonating structures will form in the reaction. Okay, Now previously also we have seen that these three structures or these resonating structures were formed in the sigma complex step of the reaction, and these all these three summit all these three sigma resonance structures are summarized into this type of the hybrid resonance structure. This type of the hybrid resonance structure, or this delta positive means that the partial positive charge is revolving on all these these and this carbon, but this carbon is not involved in the resonance. Okay, so this carbon is not part of the resonance hybrid. Now what happens in the next step? The next third step is the formation of the final product or the aromatization. What happens? This bond shifts over here like this, and again the positive charge which was coming over here get diminished and the aromatic structure gets formed. What happens? This base, this abstract this proton, and the bond between carbon and hydrogen breaks and moves into the cyclic system, and this is the first step. Hence this is not the resonance step or the determining step. So here we get the chlorobenzene as the product, and the ring gets aromatized along with the byproducts AlCl3 and HCl. One of the Cl from this moves with this or goes with this hydrogen to form HCl, and the remaining species is AlCl3 like this. Okay, understanding? Now next is the Friedel-Crafts reaction. In this Friedel-Crafts reaction we are going to see two reactions. One is Friedel-Crafts alkylation and second one is Friedel-Crafts acylation. So in today's lecture we are going to see only the Friedel-Crafts alkylation and acylation reaction we are going to look into in the next lecture. So what happened over here in the Friedel-Crafts alkylation reaction? What is alkylation? Alkylation is the replacement of hydrogen atom from benzene by a alkyl group. Is said to be alkylation reaction. Okay, an example of alkylation reaction is, or the Friedel-Crafts alkylation is, benzene on heating with alkyl halide in presence of anhydrous AlCl3 or FeCl3 catalyst, aluminum trichloride or ferrous chloride, gives alkyl benzene. Okay, gives alkyl benzene. This is alkyl and this is benzene ring, so it is alkyl benzene, and the example is suggested in the reaction as benzene. This hydrogen is going to get replaced by the, not this is the wrong structure or the wrong I have given. It should be like CH3 Cl rather than CHCl3. CHCl3 is chloroform, but we are going to use here is alkyl halide, which is methyl chloride. Okay, so this is wrong. Okay, what happens? This hydrogen from the benzene ring is replaced by this CH3 group, and we are going to get the alkylated benzene like this. Alkylated benzene like this, right? So this is alkylated benzene we are going to get from over here. Okay, this alkylated benzene we are going to form like this along with the evolution of the hydrogen. Okay, along with the evolution of the hydrogen. Okay, now in the mechanism what happens? The first step is the formation of electrophile again. Okay, what happens? This methyl chloride CHCl3 reacts with the anhydrous AlCl3 catalyst to give the methyl carbonium ion. Okay, CH3 plus, and whenever this IUM is there at the end of the letter, it suggests that it is the positively charged species which is acting as a electrophile, and this is how the first step is in the mechanism. Okay, what happens over here? This CH3Cl reacts with AlCl3 to give the methyl carbonium ion species or the positively charged ion along with this AlCl4 minus base. Okay, now again the next step is the formation of the sigma complex. Okay, This is the same step as in the previous two reactions. What happens over here, this generated methyl carbonium ion electrophile attacks onto the benzene to give the resonance stabilized sigma complex, and this reaction is very slow reaction, and hence it is a rate determining step. Okay, hence it is a rate determining step. It is a rate determining step. Yes, it is a rate determining slow and rate determining step. Now in the next step, what happens? The formation of the sigma complex. All this mechanism is the same as in the previous reaction. Instead of just this CH3 group, chlorine was there in the previous reaction. Okay, all the resonance hybrids were also same. Okay, so you understand it in the previous reaction, so I am not going to discuss it in detail over here again. Same thing is over there. Again, this formation of the product or final product or the aromatization reaction is also same, but here what happens, this hydrogen is going to get into this ring and aromatization occurs as in the previous step. But for this, the force is the AlCl for base abstract this proton to form HCl and AlCl3, and this structure gets aromatized to give us the toluene, okay, along with AlCl3 and HCl. So this is how all the reactions which are there in the benzene or the aromatic hydrocarbons are involving the basic three steps in their mechanism. First is formation of an electrophile, then second is formation of a sigma complex, and third is formation of the final product or the aromatization reaction. Okay, and which three reaction we have seen till today is, first is nitration reaction, nitration of benzene, second is halogenation of benzene, and third is the Friedel-Crafts alkylation. In next lecture we are going to see Friedel-Crafts acylation and Birch reaction. Okay, thank you.